Hello friends, in this video I am going to talk about affine cipher. So affine cipher is a special kind of Caesar cipher or shift cipher. Caesar cipher is also called shift cipher. So affine cipher is a special kind of that cipher. So let me show you how affine cipher is defined. So encryption in affine cipher is defined as if you have to encrypt a number x, so it is defined as a ax plus b mod 13, where A and B are key. So I can say K is given as A comma B. So let's say that if my A is equal to 1 and B is equal to n, then E of x will become x plus n mod 26. It's not 13, it's 26 because we are talking about alphabets. So mod 26. So this is what we have learned in Caesar cipher or shift cipher, right? This was the formula which we used to encrypt in Caesar cipher. Now coming back to affine cipher. So let's say y is defined as my ciphertext, that is encryption of x. Okay, and this encryption of x is equal to a x plus b mod 26. So I can write this equation as ax is equal to y minus b mod 26, right? Or x is equal to a inverse, this is multiplicative inverse of y minus b mod 26. So this is my decryption of y, decryption of the ciphertext, right? So here we are getting a inverse. So for a inverse to be valid, means if you want to get a value of a inverse, this a should be co-prime with 26. This is the condition which we learned when we were talking about how to find multiplicative inverse of a number. So this a and 26 should be co-primes. Co-prime means they are relatively prime, means they don't have any common factor. So GCD of a and 26 should be 1. GCD of a and 26 should be 1. Okay, so this is the condition here. If you are getting a value of a like I'm getting 2 or 13, then I can't find 2 inverse of 26 or 13 inverse of 26. So for the value of a can't be 2 or 13 because these are the prime factor of 26. Okay, so let us verify that if the decryption function which we found is correct or not. Okay, so I will give an example and verify it that if encryption decryption function is after if we are decrypting a ciphertext, we are getting the plain text back or not. So I'm not talking about alphabet here. I will just take a key and try to find the encryption function, and after decrypting I will try to get back the plain text. So let's say my key is 7 comma 3. So here 7 comma 3 means a is 7 and b is 3. The first thing we have to check is that if a is co-prime with 26. So here a is co-prime with 26 because they don't have any common factor. So we can proceed. So now encryption function. So y is equal to ex is equal to ax plus b, right? So x is my plain text. I am not using that plain text. We will use that later. So A is 7, so 7x plus ax plus b, so b is 3 here, right? Mod 26, right? This is my y. Now when you are finding decryption of y, this is equal to A inverse. So A inverse is 7 inverse y minus b. Okay, y minus b. So b here is 3, right? So let's find 7 inverse mod 26. If you have watched my last video, we have already covered this part here. We have already calculated 7 inverse mod 26. I will do it here again for your kind of revision, that you will come to know how to find the 7 inverse mod 26. So for 7 inverse mod 26, what I have to do is, the formula was, if you have to find A inverse mod n, the formula is given as A to the power phi of n minus 1 mod n. Okay, so this will come to 7 to the power phi of 26 minus 1 mod 26. So we know that phi of 26 is 12. Let me show you that also. 26 is equal to 2 into 3, 13. So phi of 26 is equal to phi of 2 and phi of 13, right? So phi of 2 is 1 and phi of 13 is 12, so I am getting 12. Okay, so 7 of to the power 12 minus 1 mod 26. Okay, you will get 7 to the power 11 mod 26. You can write is 7 squared to the power 5 into 7 mod 26. I am not explaining in much detail because I have already explained this example in the previous video. So you can always go back to that video and see this example, how I have solved this. Okay. So minus 3 to the power 3 into minus 3 to the power 2. This is 3 into 7 mod 26. So minus 27 mod 26 is minus 1. This is 9. 9 into 7 is 63. 63 minus 52 is 11. So finally I am getting minus 11, which is equal to 15 mod 26. Okay, so I can write this equation as 15 into, I will take the value of y. So value of y is y, that is ex. So value of y is 7x plus 3, right? Plus 3 minus 3 mod 26. It is also mod 26. Okay, so 3 and 3 cancelled, so I will get 105x mod 26. So I can always write this as 105 into x mod 26, right? So 105 mod 26 is 1, because 26 into 4 is 104, so remainder is 1. So 1 into x mod 26, so I am getting x here. So the equation which we found for encryption and decryption are correct. So this is my encryption function 7x plus 3, and decryption function is 7 inverse y minus 3. This is my decryption function. Okay, now let's take an example to see how exactly a plain text is getting converted to a ciphertext. Okay, so I will write down the encryption decryption function again here. According to our last example, encryption of x or my ciphertext y was equal to 7x plus 3 mod 26, and decryption of y, that is my plain text again, was equal to 7 inverse y minus 3, or I can write it as 15 y minus 3. We already found that 7 inverse is 15 mod 26. Okay, so what I will do, I will take a word, let's say I choose a plain text is equal to cat. So if you will see the numeric value of cat, so numeric value start from 0. So for a it's 0, for c it's 2, 1 for b it's 2 for c, and for t it's 19. You can do one thing in your notebook, you can write this table that 0 is a, 1 is b, 2 is c, and always refer to that table for getting the value of this alphabets. Okay, so now what I'm doing, I'm trying to find encryption of c. Okay, so encryption was 7x, so here will be 7c plus 3 mod 26, right? So value of c is 2, right? Here we saw that value of c is 2. So 7 into 2 is 14 plus 3, which is equal to 17 mod 26, which is the value of r. So my c is encrypted to r. Okay, now let's find encryption of a. So 7 into a plus 3 mod 26. So this is a, value of a is 0, so this whole term will become 0, so you will get 3 mod 26, and value of 3 is d. Okay, so this a will be encrypted to d. Last but not the least, encryption of t, which is equal to 7 into t, which is 19, right? 7 into 19 plus 3 mod 26. So 7 into 19 is 133 plus 3 is 136 mod 26. So 26 into 5 is 130, so this is equal to 6 mod 26. This is equal to h. If I'm correct, it's equal to h. A, B, C, D, E, F, G. Sorry, it's equal to G, not h. H has value of 8, 7. G is 6. So T is encrypted to G. So this is the encryption of cat in Affine Cipher, where key is equal to 7 and 3. Okay. Now let's say how to decrypt this ciphertext back to the plain text. So what I will do, I will decrypt R. My key is same 7 and 3. Okay, and we already found that the decryption function is 15 into y minus 3, right? So here 15 into y. So y is the value of r. So value of r was 17. Here you can see, right? So I can write it as 17 minus 3. Always write this mod 26 value. Mod 26. Okay. So this is equal to 15 into 14 mod 26. Correct. So what I can do is I can write it as 15 into 7 into 2 mod 26. So 15 into 7 is 105 into 2 mod 26, right? So 105 mod 26 is 1. We have seen this many times. So this will give me 2 mod 26, which is my C value. Okay. Now let's try to decrypt D. Okay. So decryption of D is equal to 15 into the D value is 3 minus 3 mod 26. Correct. So this will give me 0, which is A. So D is decrypted to A, and the last one is decryption of G. So value of G is 7, right? So I will write 15 into Y, which is equal to 7 minus 3 mod 26. Correct? I can write it as 15 into 4 mod 26. Okay, so 15 into 4 is uh, sorry, I did a mistake. It's not 7, it's 6, right? So what I have to do is I have to take 6. So 15 into 3, right? This is 45 mod 26. If you subtract 26 from 45, you will get 19 mod 26. So this here you will get T. So you can see that we got C, A and T back. So this is how affine cipher works. So that is all for this video. We'll meet you in the next video with Hill cipher. Bye for now and have a good day.